Hello. Hello, wherever you are in any part of the world. Hello from my heart to yours. We're going to talk about this Norway Spiral, which quite possibly could be a black hole that happened on December the 10th of 2009. Now, I remember this when it showed up in the sky because it was all over the news. And it was that, as you can see by looking at it, this is a sight to see. This spiral, it's like a perfect spiral right here. And this blue beam of light coming and just boom. First you see a light in the center. And then as it keeps going, then you see this big old black hole. Now, what is up with that? Well, we're just gonna dig a tad bit deeper in this. I'm not claiming to be any expert or anything, but you know, something doesn't add up to me. It does not add up. So we're gonna look at that. So what happens is the rumors, the stories start flying all over the place. And what comes out as the cover story? Well, it was just a failed ICBM test by Russia launched from one of their submarines. That's what it was. That's what created the spiral in the sky. That's what the official story was. I don't know about that. I really don't know about that. I don't.
There was a space mission to blow up the moon. Not really the whole moon. We weren't going to take the moon and remove it from the sky, but we sent up some stuff to blow up part of the moon to essentially look for water up there, find out if there was ice under the lunar surface, et cetera, et cetera. And I didn't understand all of that. I don't know enough about science to be able to explain that, but I was curious myself. So I asked a planetary geologist by the name of Emily Lakdawala to join me on the air that day. And she was able to come on and put it in great terms and explain it. So, afterwards, Emily was great on the air, and I made a mental note. Next time I need something in space explained, let's get Emily on. Flash forward a few weeks to yesterday, and there's this weird thing going on in the sky over Norway. It looked like some 50s science fiction movie time tunnel bad special effect, swirling in the sky with a blue light emanating either from it or to it. You couldn't tell. And then at the end of this, whatever it was, the middle of the spiral turned black, and the black dot in the middle got bigger and bigger and bigger. Now, this is not science fiction. This was real life going on in the skies over Norway yesterday. Having recently watched some of the TV miniseries V on ABC, I thought, aha! They probably have just released that in Europe, and this is some sort of promotion for it. Either that, or the aliens are pissed off we blew up the moon. It's one of those two. But I also said, let's get Emily on the phone, and she can explain this. So here she is. Hi, Emily. How are you today?
I'm doing great. How are you, Paul?
I'm doing just fine. What the heck was going on yesterday over Norway?
I have to say, that is one of the most surprising and bizarre videos I have ever seen of anything real on YouTube. That was pretty crazy.
And if you haven't seen it, by the way, Google it today. I had Trish do this earlier. She didn't know what I was talking about when I walked in here today. I said, did you see it? She said, no. She looked at it and she said, okay, that's not real.
It looks fake, though.
And Kyle, who is the producer of the show, looked at it and said, Photoshop.
Yeah.
That's got to be Photoshop.
Yeah, everybody says it looks fake, but the thing is that so many people saw it and recorded it that you know that it was actually real. And you also know from the fact that people all over Norway were able to see it, that it happened really high in the atmosphere. So it was real. I actually posted a video on my blog at planetary.org/blog. But the explanation is not V. It's not a light show put on for Obama's arrival in Norway. It is, in fact, a failed Russian ICBM launch.
So we're supposed to buy this story right here. That's exactly what it was. It was the missile. See how it spirals around? I don't know. I think I like this better. I like the theory that this was some great big scientific experiment. I like that theory better because it looks a lot more like a black hole that was beginning to form than this. We're looking at the Institute for Advanced Study, and they're doing a simulation of radio wavelengths, which we'll see later an image of what a black hole looks like, okay? I've done a Google search of magnetic atom creates spiral black holes. So these are the different types of black holes, you know, simulations, animations, pictures, and you see that little dark area in the middle. It looks kind of similar to that spiral that you see right here that showed up in Norway. Look, we've got this spiral too. Look, we've got these beams of light, tangled magnetic fields in black holes. You know, I seen a beam of light. We watched a beam of light yesterday on one of the Soho Lasco, I think it's C2, where the beam emanated from the corner of the screen where the sun was, and it went straight up, and then it went straight through the sun. You remember that? We got it right here so you can see that. Now here's a little thing that pulled up on the internet. What will the sun take to make it to a black hole? Well, now why they got something like that? The sun would need to be about 20 times more massive to end its life as a black hole. Stars that are born this size or larger can explode into a supernova at the end of their lifetimes before collapsing back into a black hole, an object with a gravitational pull so strong that nothing, not even light, can escape. Well, that's interesting to know that they're studying black holes. It is. This is interesting right here, and this is from CERN Accelerating Science. Black hole aligns with the sun and CERN telescope. On 18th December 2016, the sun aligned with the black hole in the center of the Milky Way, allowing CAST to search for any exotic particles it might emit. So do you see what this says? Black hole aligns with sun and CERN telescope. They aligned the sun up with a black hole in the center of the Milky Way. That was in 2016. It says yesterday, December the 18th, 2016, the sun aligned with the center of our galaxy, allowing pioneering experiment to take place at CERN. The CERN Axion Solar Telescope uses a prototype dipole magnet originally built for the LHC, which is the Large Hadron Collider, to measure hypothetical exotic particles called axions and chameleons, allegedly being emitted from the inner sun. Something being emitted from the inner sun? But on the Sunday, the sun made its annual alignment with the black hole at the center of our galaxy. I cannot believe I'm reading this. The sun can align with the black hole at the center of our galaxy, the Milky Way. The researchers haven't attempted to measure the new particles that could have been emitted by this black hole or its environment until now. So there is there's the thing right there. What's that do? No, I don't want to push it because it might be a YouTube video. We've always looked for exotic particles around the sun, doing this for years, but one specific day of the year, we can look beyond the sun to see if something more happens coming from the galactic center. Only one specific day of the year? Certainly they're not talking about the 18th of December. That's coming up. 18th of December is coming up. Until now, it's been impossible to detect particles through their specific direct interaction with matter because the equipment did not exist. But, wow. One specific day of the year. They can look. But for one specific day of the year. Let's do this. Let me see if I can highlight this, if I can. See that? One specific day of the year, we can look beyond the sun. That is very, very interesting. Black holes align with the sun and CERN telescope. Look at this tweet, and it's by CERN. Did you know? Superconducting magnet at the CMSE experiment, when cooled to a negative 268.5 degrees Celsius, a degree warmer than outer space, it generates a magnetic field 100 times stronger than Earth. Whoa, look at that. Oh my goodness, you all. Wow. That is their superconducting magnet. Look how big it is. Oh my gosh. And it generates a magnetic field 100,000 times stronger than Earth's. Wow. Let's look at this one. That is impressive. It's very impressive. Does CERN create black holes? The creation of black holes at the Large Hadron Collider is very unlikely. However, some theories suggest that the formation of tiny quantum black holes may be possible. The observation of such an event would be thrilling in terms of understanding our universe, and it would also be very perfectly safe. There's two types of black holes. They say two types, microscopic and or quantum. Scientists are not at all sure that the quantum black holes exist. So the physical part of the LHC experiments, the colliding particles, happens in nature all the time. And they know that the Earth is safe under the natural bombardment of cosmic rays, so they know that recreating these collisions pose no threat to Earth. It doesn't. So what if the collisions at the LHC produced a black hole? The creation of quantum black hole at the LHC would be very surprising, but very exciting indeed. It would allow the physics to learn about nature's most elusive force, gravity. So what would be the significance of the creation of a black hole at the LHC? The creation of a black hole at the LHC would confirm theories that our universe is not four-dimensional, 4D, 3 space plus 1 time dimension, but indeed hosts other dimensions. So they are going to open up other dimensions. They want to. It's going to be exciting. Yeah, so with that being said, this is going to have to bring me to the end of my video, you all. So you have seen what's going on, and that black holes do exist. They exist. And they want to create a black hole that would open up into another dimension. Hosts that can open up to other dimensions, other worlds. Please give this video a thumbs up, and thank you so much for watching, because there's so much to learn, and time is very short. Thank you.